Introducing the use of the machine learning in the MATLAB environment. This technique is related to the artificial intelligence. Machine learning is a discussed topic in the field of computer science, robotics, artificial vision. Deep learning is a type of machine learning in which a model learns to perform classification tasks directly from images, text, or sound. Deep learning is usually implemented using a neural network architecture. The term deep refers to the number of layers in the network. The more layers, the deeper the network. Traditional neural networks contain only 2 or 3 layers, while deep networks can have hundreds. Introducing deep learning with MATLAB. Here are just a few examples of deep learning at work. A self-driving vehicle slows down as it approaches a pedestrian crosswalk. An ATM rejects a counterfeit banknote. A smartphone app gives an instant translation of a foreign street sign. Deep learning is especially well suited to identification applications such as face recognition, text translation, voice recognition, and advanced driver assistance systems, including lane classification and traffic sign recognition. Introducing deep learning with MATLAB. UCLA researchers built an advanced microscope that yields a high-dimensional data set used to train a deep learning network to identify cancer cells in tissue samples. What makes deep learning state-of-the-art? In a word, accuracy. Advanced tools and techniques have dramatically improved deep learning algorithms, to the point where they can outperform humans at classifying images, win against the world's best Geo player, or enable a voice-controlled assistant like Amazon Echo and Google Home to find and download that new song you like. Introducing deep learning with MATLAB. What makes deep learning state-of-the-art? Continued 3 technology enablers make this degree of accuracy possible. Easy access to massive sets of labeled datasets such as ImageNet and Pascal-Voc are freely available, and are useful for training on many different types of objects. Increased computing power. High-performance GPUs accelerate the training of the massive amounts of data needed for deep learning, reducing training time from weeks to hours. Pre-trained models built by experts. Models such as AlexNet can be retrained to perform new recognition tasks using a technique called transfer learning. While AlexNet was trained on 1.3 million high-resolution images to recognize 1,000 different objects, accurate transfer learning can be achieved with much smaller datasets. Introducing deep learning with MATLAB. Inside a deep neural network. A deep neural network combines multiple nonlinear processing layers, using simple elements operating in parallel and inspired by biological nervous systems. It consists of an input layer, several hidden layers, and an output layer. The layers are interconnected via nodes, or neurons, with each hidden layer using the output of the previous layer as its input. Introducing deep learning with MATLAB. How a deep neural network learns. Let's say we have a set of images where each image contains one of 4 different categories of object, and we want the deep learning network to automatically recognize which object is in each image. We label the images in order to have training data for the network. Using this training data, the network can then start to understand the object's specific features and associate them with the corresponding category. Each layer in the network takes in data from the previous layer, transforms it, and passes it on. The network increases the complexity and detail of what it is learning from layer to layer. Notice that the network learns directly from the data. Introducing deep learning with MATLAB. About convolutional neural networks. A convolutional neural network, CNN, or CONVNet, is one of the most popular algorithms for deep learning with images and video. Like other neural networks, a CNN is composed of an input layer, an output layer, and many hidden layers in between. Feature detection layers. These layers perform one of 3 types of operations on the data: convolution, pooling, or rectified linear unit, ReLU. Convolution puts the input images through a set of convolutional filters, each of which activates certain features from the images. Pooling simplifies the output by performing nonlinear downsampling, reducing the number of parameters that the network needs to learn about. Rectified linear unit, ReLU, allows for faster and more effective training by mapping negative values to 0 and maintaining positive values. These 3 operations are repeated over tens or hundreds of layers. Introducing Deep Learning with MATLAB about convolutional neural networks. Continued classification layers. After feature detection, the architecture of a CNN shifts to classification. The next to last layer is a fully connected layer, FC, that outputs a vector of k dimensions where k is the number of classes that the network will be able to predict. This vector contains the probabilities for each class of any image being classified. The final layer of the CNN architecture uses a softmax function to provide the classification output. There is no exact formula for selecting layers. The best approach is to try a few and see how well they work, or to use a pre-trained network. Introducing Deep Learning with MATLAB. What is the difference between deep learning and machine learning? Deep learning is a subtype of machine learning. With machine learning, you manually extract the relevant features of an image. With deep learning, you feed the raw images directly into a deep neural network that learns the features automatically. Deep learning often requires hundreds of thousands or millions of images for the best results. It's also computationally intensive and requires a high-performance GPU. Convolutional Neural Network, CNN, end-to-end learning, feature learning and classification, machine learning, deep learning plus good results with small data sets. With MATLAB. Getting started with deep learning. If you're new to deep learning, a quick and easy way to get started is to use an existing network, such as AlexNet, a CNN trained on more than 1 million images. AlexNet is most commonly used for image classification. It can classify images into 1,000 different categories, including keyboards, computer mice, pencils, and other office equipment, as well as various breeds of dogs, cats, horses, and other animals. AlexNet was first published in 2012, and has become a well-known model in the research community. An example using AlexNet 12, you can use AlexNet to classify objects in any image. In this example, we'll use it to classify objects in an image from a webcam installed on a desktop. In addition to MATLAB, we'll be using the following: Neural Network Toolbox. Support package for using webcams in MATLAB. Support package for using AlexNet. After loading AlexNet, we connect to the webcam and capture a live image. With MATLAB retraining an existing network, in the previous example, we used the network straight out of the box. We didn't modify it in any way because AlexNet was trained on images similar to the ones we wanted to classify. To use AlexNet for objects not trained in the original network, we can retrain it through transfer learning. Transfer learning is an approach that applies knowledge of one type of problem to a different but related problem. In this case, we simply trim off the last 3 layers of the network and retrain them with our own images. If transfer learning doesn't suit your application, you may need to train your own network from scratch. This method produces the most accurate results, but it generally requires hundreds of thousands of labeled images and considerable computational resources. With MATLAB computational resources for deep learning training, a deep learning model can take hours, days, or weeks, depending on the size of the data and the amount of processing power you have available. Selecting a computational resource is a critical consideration when you set up your workflow. Currently, there are 3 computation options: CPU-based, GPU-based, and cloud-based. CPU-based computation is the simplest and most readily available option. The example described in the previous section works on a CPU, but we recommend using CPU-based computation only for simple examples using a pre-trained network. Using a GPU reduces network training time from days to hours. You can use a GPU in MATLAB without doing any additional programming. We recommend an NVIDIA 3.0 compute-capable GPU. Multiple GPUs can speed up processing even more. Cloud-based GPU computation means that you don't have to buy and set up the hardware yourself. The MATLAB code you write for using a local GPU can be extended to use cloud resources with just a few settings changes. Learn more about deep learning with big data on GPUs.